like to welcome you to our second Drawdown digital presentation. We're actually changing the name of it, but I'll let Laura let you guys know why. But there has been a lot of interest in the area of climate change, both nationwide and globally. And it's about time that DCIS got involved in some of these conversations involving the science, as well as what we can do on an individual level to make improvements in our lives to basically draw down and help address the issues that are cropping up. So without further ado, I'll turn it over to Dr. Gurton. Thank you very much for coming tonight.
Good evening, everyone. My name is Laura Gurton. I'm a professor of earth science at Penn State Brandywine, located in Media, Pennsylvania, volunteer with the Delaware County Institute of Science. And I welcome you to the second installment of what we initially had labeled our Drawdown DCIS series. And we've learned very quickly that there is large interest in our community for people to hear about climate. People hear the term climate change, climate emergency, climate crisis, but what's going on with climate? What does this all mean? And Drawdown is a nonprofit organization that gets us to the solutions for climate. And Drawdown has several different sectors that they have identified where there's work that is done to identify what are the sources of these greenhouse gases that are entering into our emissions. What are the ways we can then remove it, or what are the sinks for carbon dioxide? And then also, what are the other society components that go within there? So much of this was explained in our first Drawdown lecture from Matt Scott from Project Drawdown, and that recording is available online. And if you go to the delcoscience.org website, then you can actually, underneath lectures, you'll be able to see the recording of that. We are also recording this evening's lecture, so if you want to go back or share this information with others, and we hope that you do. I am showcasing one way that I use to communicate about climate solutions. So I'm a quilter as well as a scientist. And so this is on the front door of my house right now. It's a tribute to the Drawdown electricity sector and looking at energy and renewables. And I think it's great that we've got two experts with us this evening. So again, this is new for DCIS, where we have two people that are presenting tonight. And what we'll do is we'll have each presenter speak for about 10 to 15 minutes or so about their particular area. And then we'll have some conversation between the panelists. And then, of course, as always, we welcome your questions. Please post them into the chat at any time, and we'll make sure we can get through as many of them as possible. So as we kick off this discussion on electricity and renewable energy and all things power here, we're going to start with Derek Hall. Derek Hall is the program lead for the Energy Engineering Program in the John and Willie Leone Family Department of Energy and Mineral Engineering at Penn State University. Whew. Okay, Derek, I'm going to go ahead and turn everything over to you.
Let me just share my screen real quick. All right, can everyone see that? Does that look good?
Yes, we can see that. Thank you.
All right, great. So thanks for inviting me. I'm an assistant professor and the program lead of energy engineering, and we're in the Department of Energy and Mineral Engineering, where we do a lot of work with energy. So a little bit about me. My education focused a lot on the electrochemical and science and engineering of new and existing power generation systems. So a lot of my undergraduate research learned about the fundamentals of the existing power systems. Back then, it was mostly coal, natural gas, and oil. And we were thinking about renewables and that they were starting to come on the scene, but things have changed quite a bit since then. The program that I teach, energy engineering, is one of the first and one of the only programs at Penn State that actually required renewable energy courses before you could graduate. Now, as a professor, I spend a lot of my time doing research with industry and the federal government to try to sustain and improve our energy infrastructure and find ways of making the system overall more sustainable and more beneficial to all of us. So this was Drawdown. So a lot of what I'm going to go over is some of the links with CO2 production, which is a key theme in Drawdown, and how that relates to our daily habits. So CO2 production has been continuing to grow despite global efforts to curb the emissions. And if we kind of look on this plot, I'm a scientist at heart, so I love plots and simple ones at that. We can see that it went up pretty dramatically and it started to level off, but we're still seeing some ticks up. And that's not a good thing, because even though it's leveling off, which sounds great, what we really needed to do is to go the other way. And the real thing that we want to target is we need to cut these emissions in half by 2030 or sooner to avoid some severe ecological disasters and concerns. It's going to make it very uncomfortable. So a lot of the content I'll be presenting today came from a group in Sweden. So this is just one take on this, but there are several other studies that point to a lot of the same things. So the next question is there any hope? Well, one thing that's changed considerably, at least in the electricity markets over the last 10 years, is renewables are now cost competitive with other systems. And that's without accounting for a lot of the known health and environmental impacts that some of them have. And because they're cost effective, this isn't just something here in the US. Globally, over 90% of all new power generation that's been added has been renewable because of this. So that cost competitiveness, even without taking into account these impacts, is really driving a big push towards that. And we're starting to see some of the same trends that we saw in the renewable power generation to happen in transportation as well. So along a few years back, all electric vehicles were not really seen as often, and now many companies are making pledges to move to all electric vehicles and to really expand this. And to get a nice picture of what that looks like as far as the cost competitiveness goes over that short time period, you can look here at solar voltaics and just see that fossil fuel price range that we've kind of narrowed in after several decades of improving the engineering. And you can see a lot of these new systems quickly getting into that region where, depending on the location, many of these new electricity generation systems are quite competitive. So we were leveling off that CO2 emission, but how do we really make deep cuts? So there's a lot of different industries that we can target, each of them allowing us to get rid of those 30 some odd gigatons of CO2 we emit each year. And these are some of the profiles that we have. So focusing on electricity, one aspect that's going to make a big difference is us slowly implementing more photovoltaics. This is really going to take up a big chunk of the pie, but it's still not going to get us to a 50% reduced emissions from energy supply. So in addition, we're going to have to bring up a few others, and we're going to need to try to reduce some emissions that we haven't been tracking as well as we should. Moral of the story is, by fixing our energy supply, that's not the only thing we need to do. We need to look other places that also have some electricity and energy implications. And some of those are just by reducing our total energy demand, such as building retrofitting and modifying our industry practices, right? So each of these lists off different key objectives that we can accomplish to try to get significant cuts in our emissions. So what can we do beyond just those? So some other interesting things we can look at is transportation, which is another sector that uses quite a bit of energy and results in quite a bit of emissions. So moving to electric vehicles will move a big portion of the pie in getting us closer to where we want to go. And then finding strategies for low emission heavy vehicles, which is a bit more challenging, where electric vehicles won't work. People are considering things like hydrogen energy to try to power our trucks and our trains. Another big thing will be pushing towards mass transit again and moving people towards cycling. So some simple things. Some interesting ones that I was surprised about are personal habits, where we can try to eliminate further growth in our emissions by picking better foods to eat and reducing some of our waste. These lead to increased methane emissions, and there's also some additional emissions associated with certain food styles. So we can actually, this is basically curbing further growth, right? Population keeps going up. So changing our food consumption habits can help us there. And there's also some interesting thing we can do with natural resources. Forest protection is a really important one. So trees are one of our best tools for pulling CO2 out of the air. And likewise, reforesting and improving fertilizer management can help us a lot to naturally try to curb some of the emissions that we've had so far. So I'm an electrochemical engineer. So what I try to do is focus on novel ways we can use electrochemistry to try to help some of these emissions. And for each of those big chunks that we talked about before, I'm just going to explain some of the technologies that we're researching and trying to improve to help make this possible. The first is about decarbonizing our electric grid. And the way we want to do this is to add grid scale electric energy storage. So some of these are happening in the form of lithium ion batteries to help our solar panels and to try to improve them and make them more reliable. So by themselves, they're intermittent. But if we couple them with energy storage, it can help us to achieve these gains. The next one is decarbonizing our transportation system. The one you may have heard about is electric vehicles, but the more important one, oops, sorry, it's getting ahead of me, are hydrogen powered vehicles. So this is a way for us to get more power density and push some of those heavier lifting jobs that batteries just aren't prepared to do. And the last one that I'm having a lot of interest in recently is improving energy efficiency by developing thermally rechargeable batteries that can capture waste heat. So there are a lot of manufacturing processes that we have that expel waste heat around 100 degrees Celsius to 150 degrees Celsius. And we're working on trying to identify technologies such as batteries that we can use to harness that waste heat in a way to charge them to provide additional electricity from heat that would otherwise be wasted. So by providing more electricity from the same energy input, we can actually improve the efficiency in our use of carbon-based fuels to try to get a little more electricity out of the ones where we need them and it may be more difficult. So that's sort of the big picture on what's going on in the world and what we're trying to deal with. But I wanted to also include a little bit about what each of us are doing. So Bruce Logan at Penn State came up with a fascinating way of us to quantify energy so that we can figure out how to assess what we do in a daily day. And he calls this the unit of energy is 1D. So the amount of calories it takes each of us to survive or to recommended calories for a day is about 2,000. And if we take this, we can essentially go through and identify how much energy it takes us to do some basic things that we have. One would be running an old 100-watt light bulb in a day. It takes about 1D worth of energy, so about 2,000 calories. The average electricity use for one of our houses is about 13 days. So you can see that there is quite a big difference, right, between how much energy it takes one of us to keep going day to day versus running a light bulb and versus powering our house. The same for gasoline, some natural gas used to heat our house. So what's surprising about this is that when you add all of this up, each person in the US uses about 102 Ds worth of energy, whereas other countries use about half of what we do. And some interesting things that we can do to try to improve this is, say, instead of use a 100-watt light bulb, we can go with LEDs that are maybe about 10 volts, and you can see a dramatic reduction in the amount of energy we need. Another example would be an old refrigerator that may take 1D, whereas if you get a more efficient a piece of appliance, you can cut that down quite a bit. So how does that help us with drawdown? Well, what that does is essentially we need to come up with another unit, which is how much carbon dioxide do we emit for each of those? So the reference point that the Logan group came up with was that, naturally through breathing, we release about 2 pounds per day of CO2. So we're going to call this the unit C, right? So now we can do the same thing. We can go through and say, well, some of these decisions, we need energy in order to do, to conduct our daily lives. So how much carbon is associated with that energy? So for example, gasoline, there are some, right? And as we get to the more different fuel types, we have different values of C, and that's because of their chemistry. And the power associated with them also changes. So if we make a ratio of these two, you can essentially see how much carbon you're getting for the same usage of fuel. And you can use this to try to guide to some of your decisions, right? So if I need energy, is the energy I'm using coming at a certain cost? So the example I'm going to leave you all with is home heating, something that we all have to deal with in Pennsylvania. So here is that sort of breakdown of some of the common examples we have, right? We have choices between natural gas, oil, electric, so such as baseboard, and heat pumps. These are the efficiencies and the typical costs, which are some of the engineering terms that we work with. But if we put them in these units of how much energy in terms of D do we need, how much fuel is required of those, and how much carbon is emitted to get to each of those. You can see some clear differences, right? Even though baseboard electric requires a fair amount of electricity, there's some fuel behind the scenes that needs to be burned in order to get us that usable energy that we use in our house. And that fuel comes at a cost. So if we compare that to using natural gas directly, where using heat from a natural gas system, using fuel to produce heat is generally more efficient, we can get to lower values of C. But one of the best is to use a heat pump, which is much more efficient than electricity. And this whole situation gets much better when we replace fuels with solar panels. And instead of us having this C associated with the fuel, then we can use these electric options to reduce the C component to get to our same energy needs. So that's everything I have for you. I guess, do we want to do questions first, or should we let Alon speak?
We're going to go ahead and let Alon speak, and then we'll do some questions. As you can see, probably already, Derek, there's a couple questions that have come in on the chat. So again, as you have questions, please put them in there and we'll make sure we get through to them. But now we're going to shift gears a little bit and we'll go to our second speaker to get a snapshot from the Philadelphia Energy Authority. So Alon Abramson is a program manager at the Philadelphia Energy Authority. And so I'm going to go ahead and turn the Zoom room over to you.
Thanks so much. Okay, good. Making sure I'm unmuted. Let me share my screen for everybody here. I have a similarly brief presentation, but I am very thankful for Derek for giving the high-level overview of this discussion topic, so that I can kind of dive in on what we're doing at the Philadelphia Energy Authority in terms of kind of trying to realize this drawdown, right? This vision, and understanding all the implications of climate change and just the real deep need for kind of starting to implement all these things that we know we need to be doing. And we're thinking about this at the Energy Authority from a very economic drive kind of perspective, right? Like, how do we get people to make the investments that are needed in order for these things to happen? I saw a question come through on hydrogen and what the challenges are going to be for hydrogen infrastructure rollouts, and it ultimately kind of is the same kind of question of how do we pay for it, right? Those are the questions we're trying to answer. I didn't create a about me slide, but so I'll just kind of give that background right now. I am a civil engineer by education, civil and environmental engineer, I should say, from Lehigh University. I started my career in consulting, which I did not very much enjoy. So I actually transitioned to university research, really immersed myself in clean energy best practices, kind of the city scale, so understanding what kind of the different economies were doing, different countries were doing to start to address climate change needs, whether it was from the utility sector, transportation, or buildings, whatnot. And then from there, transition to the Energy Authority, where I am now. And my role here at the Energy Authority is really to develop new programs that are trying to accelerate this investment in clean energy in the city. So just a little bit about the Energy Authority. We're a government agency. We're an authority, which is just an agency type in the Commonwealth, and it allows us, being an authority, allows us to hold long-term contracts. Where again, because energy is really these investments are kind of driven by payback periods. You typically see 15-year, 20-year, 30-year contracts being required to make a project kind of pencil out. And so an authority is really the vehicle that you need for a city like Philadelphia to make these kinds of investments in things like major buildings, infrastructure, things like that, which I'll talk about a little bit in the next slide. But really what we're excited about is the idea of using energy as a tool for impact across the city. So as we kind of think about drawdown, how do we kind of bring everybody with us, right? There's a real concern here that as we transition from fossil fuels to clean energy, that some folks get left behind, right? If I can put solar on my roof and electrify my home, kind of decouple myself from the gas utility, and more people are doing that, and that are able to afford to do that. It sort of leaves folks who are lower income, can't make those investments in their homes on their own to support this kind of legacy fuel that gets more and more expensive. So we're trying to think a little bit more holistically about the systems here, and figure out how we can use energy as a tool for creating driving economic development, but doing so in a way that we are also creating local jobs, especially for folks who have been marginalized in the past. And that in turn can alleviate poverty, but there's also direct investments that we can make in communities that are poverty alleviating. And I can talk a little bit about that as well. And there's a piece here that's really exciting, where we can actually have tangible impacts on public health through these investments as well, especially when we're removing fossil fuel combustion pretty much in any scenario. That's going to be a net positive. So the Energy Authority, we operate on what we call the Energy Campaign, not the most innovative, creative name, but it is kind of bookended by a couple of really big numbers. In a 10-year period, we're now in our 5th year. We're looking to bring $1 billion of investment. This is really how we think about things, very economically driven. $1 billion in investment, which we see creating 10,000 jobs. We're looking at at 4 major sectors. We're really focused on the city's buildings and infrastructure, as well as the school district. Those are kind of like larger sectors. Government, really hard to move because government is just really hard. So it's hard for the private sector to get projects done. So we're sort of the lubricant in that side. And then the other 2 kind of more impactful sectors on the ground are low-income housing and small business. And so all of our programs are really trying to kind of maneuver in those 4 different sectors. Some highlights over the last 4 years, which I should say, in that period, we've brought in $167 million of investment, 1,700 jobs. It looks like we're not necessarily on track to hit that $1 billion goal, but really we're just we're like hitting our ramp up mode right now. So we're expecting more of a hockey stick kind of growth in that investment in the next 6 years. We've helped the city procure a 70 megawatt solar power purchase agreement that's going to support 22% of the city's electricity production, or demand rather. That's a solar power plant that's going to be built out in Adams County, PA. We supported a $12 million project at the Philly Museum of Art to reduce that building's energy consumption by 25%. Again, really like we're doing the thing, right? We're trying to reduce energy demand, which is obviously one of the methods for drawdown. We're doing so with investments in schools. These are energy performance contracts that we put in place, and then kind of more on the ground level, where we run the country's largest Solarize program. Solarize is a bulk purchase type of program. We run it annually over a period of about 4 months. During that time, people can sign up. We have set pricing, set equipment, set installers, everything's vetted, really like safe, comfortable. Everything's like going to be okay. You can go solar. It's going to be good. And you have to sign a contract before that ends, right? And that also helps compel people to sign up. And so we've had $12 million of residential solar installed over the last 4 years. And we're getting ready to launch our 5th round of Solarize this year, next month or so. A couple of other things we do. We have a financing program that we run, the Commercial Property Assessed Clean Energy Program that helps commercial industrial properties also pursue energy projects. C-base, I don't want to spend too much time on this, so we can have a little bit more time for conversation. But again, we've kind of institutionalized a lot of the support that's needed for property owners to pursue an energy project in their building. There's a lot of kind of question marks, a lot of noise in the market, and it's really a lot of solicitations coming at owners, and they're not really sure what to trust. So we at the Energy Authority, or the government, we're basically providing some guardrails for folks, creating helping with contracting and things like that, so that they can pursue energy projects on their own. We just recently helped the Curtis Institute of Music, which is a music institution downtown in Philly, has a 5-building campus. Help them basically do the contracting assessment for the project and pursue a $650,000 project there. And then we're in the process of doing something a bit more kind of universal for multifamily properties in the city, where we'll kind of give people a good idea of what energy savings potential there is in their buildings, and then we can help kind of handhold them through the process for pursuing projects. And these, really, we're considering energy efficiency and solar power, on site, really as a, one and the same, in our, when we talk about projects. We do have our separate Solarize program, but when we talk about the commercial sector, it really is, what can we do to reduce your energy cost overall? That there's going to be some piece of that's efficiency and some piece that is renewable, ideally. I'm excited about this program called Built to Last. So I'll run through really quick, but what we're really trying to do in the low income sector is, our goal again is to reduce energy cost and energy burden for households. We realize that for homes that are not necessarily well maintained, especially intergenerational homes, where if somebody's been kind of low income for a long period of time, they aren't necessarily being able to keep up with maintenance. Before we can go in and do energy efficiency work and solar, we have to make sure that that home is really fundamentally kind of sound, right? That we are addressing the basic systems needs, and then once those are addressed, then we can start thinking about weatherization, what health and safety issues, do we need to address? And then what we're excited to do is add solar, look at electrification, so swapping out gas or oil combustion for electric heat pumps that Derek was talking about, and really get those homes not only kind of back to a state of good repair, but really ready for the 21st century, right? So our goal is to really stabilize communities by making these homes incredibly affordable, right? Where we reduce energy utilities down to nearly zero. Everything's electric's covered by the solar on the roof. The house is now comfortable and healthy, and everybody can stay, and they're not kind of as susceptible to development pressure as they would have been before. And this diagram just kind of shows the process that we're looking at to pursue that program. There's multiple programs we're sort of bringing together, so we have to screen everybody for those programs, assess the property for all those needs, then manage the construction so that everything's kind of done in order by the right people, so we're not redoing work, and so we can do this quickly, so people are satisfied. I mentioned earlier the Solarize program. As of today, actually, I think this number might be a little higher now, but we're right around 750 contracts signed. We've installed 3.3 megawatts of solar capacity, and a lot of money. It's created jobs. I will kind of take the air out of my sails here on this slide. For this audience, this 3.3 megawatts over 4 years is not even close to fast enough, and not nearly enough deployment. The state of Pennsylvania is really challenging. We don't have community solar. We have very, very low cost solar renewable energy credits, something we can talk about. And the incentive structure is just not as robust as it is even just across the river in New Jersey, where their solar renewable energy credits are, I think, 10 times as high as ours. So that basically means for your system, every megawatt of power that it generates, megawatt hour, you get $300 if you're in New Jersey. In PA, you get $30. So as you're thinking about this investment, how quickly will it pay itself off? Quite a lot slower in Pennsylvania than in New Jersey. And yet we're at the position already where solar is at cost parity, if not cheaper than just staying with Pico or going with a different retailer. But it's just not as compelling as it would be if we had a more robust market. So we're working really hard. We're trying to make solar clearly okay and like a normalize it. But there's a lot more work for us to do there. And then on the kind of the backside of all of this, we run a set of training programs. We're trying to really align the work that we're doing on economic development with the jobs on the back end of that, right? So if we can create more economic demand for these kinds of services, we want to make sure that people in the community, especially those that have been historically underserved, are in the positions to take those jobs and kind of run with them. Start as laborers perhaps, but then get into the position where they can start running their own businesses, and that kind of then builds on itself and can start accelerating those deployments. So we run one program that's focused on solar and one that's focused on the kind of clean home, the green home retrofit side. It's one piece on home electrification. I think it's worth saying. There's a lot of good it can do. On the one hand, huge improvement in energy performance on the HVAC and domestic hot water side. Especially now, modern heat pumps operate in cold climates, so they still provide heat even when it's very, very cold. They pull heat out of the air and move it into your house in the winter. They pull heat out of the air in your house and move it outside in the summer. That's really how they function. And because they're not combusting, they're not using resistance like electric resistance heat, they can have efficiencies of 300%. So it's more of a refrigerant cycle driven process. So incredible performance, but there's additional benefits there as well, especially in Philadelphia, where we have a lot of older homes. Central air conditioning is a huge luxury, very rare. Heat pumps provide the opportunity to add air conditioning to homes that have never had it. They may have a set of window units, but there are a lot of kind of warmer spaces in that home. And then there's the ability then to dehumidify the space more kind of systematically, and then also remove potential combustion byproducts from your legacy combustion systems. And then, as I mentioned earlier, we're really excited about the idea of coupling heat pump systems with solar on roofs to bring those costs down. So hopefully that was not too much too fast, and we have plenty of time for the discussion.
Alon, thank you so much for all of that information. And we're going to make sure that we get the links that both Derek had in his presentation and yours on our website for our series. So we have some questions that were submitted ahead of time, and we have questions that are starting to appear in the Q&A in the chat. But I thought we'd start off a little bit different, though. I know I have served on panels before where I've heard other speakers and I'm like, oh, I wish I got to ask a question because they said something that I thought was really interesting and I want to learn more. So I'll open it up to both of you. Do either of you have a question for each other on what you just heard that you may want to ask about?
I have a question for you, Derek. I hadn't heard of the this idea of using thermal energy for kind of for battery charging. I mean, that's how I'm summarizing it in my head, and I'm really curious what the state is of that technology and how you see that kind of benefiting just generally the electric grid.
Yeah, that's a great question. So with most exciting ideas that are new, so they're still underdeveloped. So we've been working at Penn State to try to improve on this space. So we recently have had a lot of success in getting the power you can get out of a unit per area much higher. So there's a few other competing technologies that do exist. So we've had some good progress, but there's still a way to go. So there's some funding in that, but it's still in the research stage. I would say 5-10 years would be optimistic if we do see it. Or maybe something else will pop up. A lot of people are looking into it because about 75% of the energy is wasted from what we get out of fuels right now. About 25% of it actually goes to what we want it to. So even cracking a little bit of that pie in a profitable way would actually reap a lot of benefits. So hopefully we get some progress soon. I did have a question for you, Alon. So the increase in heat pumps and solar, so that's really taking off in Philly? That's really great to hear. Do you think we're going to be able to sustain
I won't say
that?
Yeah, I won't say that anything's taking off on the heat pump side. We're at the ground floor right now. That program I described, the Built to Last program, is going to be our testing ground for that. We'll obviously model out scenarios and make sure that what we install in homes is going to be more affordable and, kind of more, just more manageable for the households we're serving. But we see that as, there's just so little information about what it takes, what are the economics, what's the end cost of utilities of going, from oil or gas or electric resistance to heat pumps and retrofits. We know it's great for new construction. Like it's like a go. Everybody's like all about heat pumps and new construction, but we're really just starting to get into it for these retrofits. So I think right now it's very small. It's probably like a couple of percentage, percent of any new system that's going in or replacement system. We're hopeful to change that.
Yeah, but that's still promising though. I mean, I think there's a lot of existing infrastructure, right? So I think retrofits is where the biggest battle is going to be. So the fact that it's even started now, I mean, at least I remember heat pumps having a bad reputation a long time ago, but it seems their construction's gotten a lot better. So it's nice to see that it's actually getting some adoption.
One of the things we're going to have to battle actually is that piece. I actually just heard a great podcast about this. So if anybody else is a big energy nerd here and wants to listen to podcasts on the side when it's actually still your job to do this stuff, I think it was on Energy Gang, excellent podcast. But they were basically discussing all the challenges of heat pumps, right? All the potential, but all the challenges and the legacy. The historic reputation of heat pumps, the technology as it was in the 90s, really contractors had very bad experiences with it, and a lot of complaints from customers. So there's a lot of re-education that needs to happen on that side, and just explaining that the technology has gotten much better. They're really robust. The construction is great, to your point, and they really function just like air conditioners, but they just have a reverse valve that allows them to heat, and that heating ability is now much better. So you can you'll heat all Philly winter. It's not going to bring just tepid air into your house. So that's one of the challenges. But yeah, right now I think if it's an emergency and somebody's going to go replace their system, there's a very low chance they're doing that with anything but what they already have. Right? If it's gas, they're going to put gas in.
So heat pump seems to be a popular topic on the minds. If you go to the Q&A, there are two questions in there. One says from Sue, I think you showed in one slide a heat pump costs less to operate than gas. I thought the opposite was true as of now.
Yeah, great question, Sue. It likely does cost more to operate. The fact is, especially in Pennsylvania, the cost of gas is just so low compared to the cost of electricity that initial operating cost is likely higher. And that's why we're really excited to pair that with solar. I think that's where you kind of run, that's where you find the magic, is that you displace that gas with electric, and then you displace all that electric need with your own rooftop solar. At least, we do have a net metering in Pennsylvania. So in the winter, you may not be generating that much, but you can overcome that in the summer as long as you net out 100%. You basically displace all that additional cost, the additional potential costs from the heat pump. But that's the math we're trying to do as well. There's a lot of speculation that the heat pumps would cost more, but we don't know. But we're just operating on that assumption. The technology has gotten a lot better than, and the research and real life demonstration hasn't kept up with it. So we'll be very cautious, and our goal is to never have anybody pay more than they were paying before, especially with the population we're trying to serve. Energy burden is already a huge problem. So we need to make sure that people are going to be spending less. But within that kind of frame, we still have a lot of potential, because there's a ton of oil still being burned. And there's a lot of electric resistance heat. And those are definitely going to be cheaper scenarios.
The second question in Q&A, Derek, I don't know if this is maybe one for you. Do we have a graduate student somewhere that might be working on this? How close is the industry to having heat pumps that work with hot water radiators? Do you know about the status there?
Oh no, I'm sorry, I don't.
It's a good question. So I guess the question is on whether you can have a system that's creating enough heat to and then, yeah, to then cycle through your radiators. I haven't actually heard of that necessarily. I know that there are water-based heat pumps, water source instead of air source. And there are heat pump water heaters. So there might be some, chances are that this exists. I just don't know about it. It's like a radiator or a boiler replacement heat pump.
If we look over to the chat, Morris submitted a question. What do you know about decentralized energy sources such as cold fusion?
One's definitely you there.
Yeah. So hot fusion definitely has a lot of technical challenges, and so does cold fusion. I think at this point, scientists are still arguing whether cold fusion is even possible. And then even on the hot fusion side, they're still just trying to make it produce more energy than they're actually putting in. So if those will ever come through, it's going to be a ways into the future, because they're still at the ground level fundamental research.
And one of the questions, Derek, that came in on the registrations for this webinar, what's the latest on nuclear fusion electric power production?
Yeah, fusion's the same one. That one's difficult. Fission is the one that we currently have built everywhere. We are trying to improve those devices because they do provide good base load energy, and we can also use them to produce hydrogen gas, which I think is another question I'll get to later. However, they cost an extraordinary amount to build, and they still build on a centralized system, which is pretty challenging. And at least in the U.S., we're also struggling a lot with what to do with all the nuclear waste. It's a political hot potato that's really difficult with a lot of long-term issues. So it just, until we can get a more unified strategy for it, a lot of people are shying away from it. It's too costly, and there's too much public interest against it.
So you mentioned the word political, and I think sometimes there can be tension when you speak about and just energy in general. So I was in a meeting earlier today where someone was pleading, let's stop saying alternative energy. Let's stop saying green energy. Let's just say energy, because that's what it is. And it happens to have good outcomes and good outputs. And I'm wondering if either of you have come across this, where when you're talking about looking at new directions, looking at drawdown, right? Looking at reducing emissions, if sometimes our vocabulary is getting in the way, where we aren't able to have the conversations within the communities that we would really like to.
I love that question. I think so much of the challenge that we're running into, especially now that the economics, as Derek pointed out, are there, right? Where solar is often just as costly as just continuing to buy electricity from your utility. I think a lot of this is a mindset, and just people understanding that this is a normal energy. This isn't kind of novel. This isn't the future, and it's not scary or untested or those kinds of things. So I do think the language we use is really critical to that, and continuing to normalize. Like I used that word earlier, and it's real. I think that those are the kind of market barriers where we run into a lot, is fear of adopting something because it seems new or it seems novel. So yeah, we should probably stop saying alternative energy and just start saying clean energy or progressive energy, or I don't know, like better for the world energy. I'm not a marketing person.
Yeah, as a scientist, I find this I find it frustrating, just because I look for answers and good solutions to problems that benefit everyone. So I don't care where the idea came from. I just more worry about its outcomes. So in that respect, I also believe, at least for our local communities, if we're leading the edge in future technology that's going to benefit us, and then people are going to ask for our help to do things, which is usually a good economic standpoint to be, right? To be the innovators rather than the people following behind trying to catch up. So in this case, it just really seems like this is the way of the future, and we can either be the ones pioneering it, or we can be buying it from someone else. And I'd always rather be working on the new exciting things, even though there are some risks, but there's also rewards that come with that too. So I'm going to go with adventure and say, yeah, we should just call it new exciting opportunities and better ways to live, right?
So speaking of opportunities, we have another question that appeared in the Q&A, but we also had one submitted on the registration form asking about microgrids. And so I was wondering if either of you can answer, are community microgrids legal in Pennsylvania?
Yes, I think the answer to that is yes. I think it's less of a legality question and more of a practical application question. I don't know, Derek, if you want to add to that.
So I tried looking into this because I'd never thought about that before. And I think the answer I gathered so far, which is a premature one, is that I don't think we wrote our laws very clearly about them. And so now that they're a new thing, it's kind of it's like a gray area. It definitely doesn't say no, but it also doesn't acknowledge their existence. So I think we're kind of in this weird in between. So I'm not sure. That was the best I could get from 10 minutes of Googling.
That's fair. Yeah, and the places where you do see them implemented are usually very large entities, like large campuses where they can kind of they're almost like their own load serving entity anyway, so they operate under different rules rather than like really a community microgrid concept where it's a set of households. I think
I'm not sure if it's well defined, and I think that in lies the problem, right? At what point does it become micro? If there's not legislation behind that, then I think it's sort of the Wild West, as it were.
Very true. I think there's a lot of dynamics happening in the grid right now, and like for grid operators, Derek, on your end, the kind of increasing ubiquity of storage, especially kind of small scale storage, I think is very intriguing to utilities that are trying to manage demand. And increase resilience, and so there's a lot of ideas about can we get 100 homes all kind of grouped together so that we can kind of control that power and call it like a small virtual power plant basically, and there's a lot of those kinds of conversations happening, and like basically the rules are being written as we speak, to Derek's point.
Yeah,
it's an exciting time actually. It's for those who are kind of in the audience that are like getting into this field. We haven't figured it all out, that's for sure. So you're coming in at a great time when there's so much to still get sorted out.
And speaking a little bit about infrastructure, so Derek, you had mentioned during your presentation about hydrogen. I think it was with regards to vehicles. And so could you talk a little bit more about some of the challenges associated with converting to a more hydrogen-based economy, building up the necessary infrastructure, for example?
Sure. So the interesting part about hydrogen is we already have a lot. We use it so much. It's key to making all the fertilizer that we use to feed our fuel, ourselves, I should say. We also use it to synthesize gasoline. And we already have an incredible natural gas infrastructure to transport everything around. So a lot of the pieces are already there. I think the real critical part that's not there yet is hydrogen production from renewable sources. So water electrolysis is there, but it's still expensive because natural gas is extremely cheap. So if you can crack natural gas to make hydrogen, which is basically what we do almost everywhere, that's what we're up against. So once we get that part of the puzzle figured out, which again, it already works, it's just a little more expensive, and like everything, solar and batteries, the more we build it and the more we do it, the cheaper it gets. It just hasn't hit that critical mass yet where it's there. But once we do it, we've been moving gases around for a long time. So I think we can quickly start to adapt and deal with some of those infrastructure issues. But it's not like the electric vehicles where we don't even have any of the stations, right? So I think it's closer than we would think, but still some challenges for sure.
Great answer. I got nothing to add to that. I think I will just echo that it is our bigger challenge is definitely on EV infrastructure and that deployment. That's going to be a big one.
Another question. Actually, one just popped in. Let's keep going with the hydrogen here at the bottom of the chat regarding hydrogen versus electric vehicles. Do you foresee these two options coexisting? Will one method of alternative fuel vehicle dominate?
On the record on this one, Derek?
Oh, sure.
I'll go after you.
I think they'll both coexist. I think they do two different things. Electric batteries, especially because they're so modular in design. They work really well for small getting here and going there sorts of things. There are some supply chain issues. I think some questions about how much of those materials will be around in the long run, and if everybody in the world decides to have an electric car, then yeah, we might start having some problems. But at the same time, hydrogen has a similar issue, except it works really well at moving very, very heavy things. Electric vehicles will absolutely never do that. And they will never, well, I won't say never, but for quite some time, given what I know, they will not be pushing planes through the sky either. And we'll need those, but they can be done with hydrogen. So I think it's more of a move the heavy stuff with hydrogen, the light stuff with batteries, and that's probably going to work for at least the near future, unless something changes. That's my best guess.
Yeah, yeah, I completely agree with that. I think, yeah, there's a kind of an energy density question here, and yeah, the batteries just don't have the density required to do heavy equipment, and as well as the kind of throughput, I guess. I don't know I'm not thinking of the right term here, but just especially for things like large trains and heavy duty vehicles, you just need a lot of power relatively quickly, and you can't discharge a battery basically quickly enough to meet that demand. So yeah, for now, and I think all the market's sort of coalescing around this idea that we've got the heavy duty vehicle side that's more hydrogen centric, and then the light duty vehicles are kind of, people are really moving more into the battery driven side there.
In the website that we have where we promote this lecture series, we link to individual episodes of a podcast series that was created in 2019 called Drawdown in Pennsylvania. And the podcast, one of them is on the transportation sector, where there was an interview done with SEPTA and talking about why there aren't more electric buses. And part of it was, it's a different battery. You can't just plug into the same place that you plug in a car. And then when you look at the time that the buses are on the road and the length of the routes, and you can't just park somewhere and recharge the bus during that. And so SEPTA's been doing a lot of exploration too about why, what the challenges are. And part of it is, again, keeping that energy and being able to power the buses where you need to. So yeah, I think a lot of that, the energy, everything from the harvesting to the storage to the you name it, there's still ways we need to go with the larger vehicles.
Yeah, for sure. I think what's funny, maybe ironic about the SEPTA, the public transit side, is that we sort of had figured out electric, vehicles. Like we have trolleys, we have overhead wire driven conveyance, and I think we moved away from that, and now that it is still a feasible option. I just think the battery powered vehicles are the kind of shiny new things. So we may already have the solution in front of us.
We had another question that came in earlier about asking, does the timing of infrastructure development affect how quickly we can transition to electric? How might we spur this onward?
Yes.
I can try. I think it's all about adoption, right? As the demand for one thing goes up, that's the one thing that speaks pretty true here. If you want something to go faster, spend money on it. So whether that's through public policy or that's with our personal checking accounts, sort of, if we can find a way to get a little bit into there, it's going to help out, and right, every little bit helps. So I know I'm personally trying to look for a small electric vehicle to get me to my job each day. I'm thinking maybe like a small electric Vespa, but we'll find something. So once these things come onto the market, same with like bicycles that have batteries on them, they're pretty small, but they can be really beneficial, especially for small transit. So I think it's little stuff like that, electric vehicles, and we'll get there.
Yeah, and one thing I want to add to that is the kind of flip side to that is that the more infrastructure investment that we're making in like gas infrastructure and things like that, that we ultimately want to move away from, the harder that gets, because now those plants or those pieces of infrastructure usually have at minimum 15-year kind of like payback periods, right? Like that's how long they're sort of budgeted to exist. And it's usually, it's like for the utilities, they're looking at revenue in the future that's going to pay off those investments, again, for the next 10, 15, 20, 30 years. So anything built today, if we somehow transition away from gas, we're still paying for it. Somehow we're going to all pay for that. If it's not by selling gas, it's going to be by writing that off, and everything else sort of gets more expensive. So yes, it's very important to start making those investments ASAP. And I think this is where kind of we all can probably play the biggest role, is some political activism there. A lot of these at this point when we're kind of at price parity on renewables versus gas and these legacy sources, it's really more of a political obstruction that's preventing things from happening. So the more we can kind of use our vote to move in that direction, the better. It's my one political thing I'll say for this. Politics do matter. It's real.
We are getting close to the end of our time. I do want to give each of you a chance, though, if you have any summary statements that you'd like to say. And while you reflect upon that, I'm going to go ahead and share my screen to show everyone that as a part of the Drawdown DCIS series, we are also encouraging everyone to participate in the Drawdown Eco Challenge. We are asked several times, what can each of us as individuals do? Some of us, we don't own the homes that we live in, and so we can't retrofit to be energy efficient. We have a gas powered car. We don't want to all of a sudden switch, because then we're generating waste if we dump a perfectly good vehicle that we're using. And so what are things we can do? And so with the Drawdown Eco Challenge, there is a whole list of suggested solutions underneath the electricity sector. And so the link is in the chat, correct? We encourage you to check this out. Again, you can sign up and be a part of the Drawdown DCIS team that is working on this, or just take a look at these options and consider engaging in some of these practices yourself. Again, some of these are individual activities, calculating the carbon footprint of your household. Again, if you click on learn more under each of these boxes, it'll give you the information that you need. Choose renewable energy or purchase renewable credits. Choose LED light bulbs. There was one here, learn more about wave and tidal energy. That, as an oceanographer, that's something I have a big passion for. So we encourage you to check out some of these options that are listed here, that are activities that you can participate in your household. You can share this information with others as well. And then while I'm sharing my screen, I will just quickly jump to, we have another lecture next month that'll be addressing the food, land use, and agriculture solutions for Drawdown. And so for those, we have another person from Penn State University and someone from UC Irvine. And in this description, you can see the range of topics they plan on talking about what happens here in the US. Again, it's a global food system. It can impact people and communities outside the United States, how technology is being used, what's happening with farm energy and conservation on farms and such. So this should be a dynamic discussion again, and we encourage you to go ahead, and the registration is open to sign up for the next one, but we're not done wrapping up this one. So Alon and Derek, if there's any final thoughts or take home message, calls to action you would like to make for us as well.
Sure, I'll take that up first. I just really want to encourage anybody who's interested in this space. You don't have to be an engineer. There's so much work to do here, both from like the organizing side, the finance, there's obviously a lot of engineering work to do, but really every aspect of our economy basically needs to be mobilized to move in this direction. So I just really want to put that call to action out there. This is obviously the most critical challenge that we're all facing, and it ties into everything. So if you're interested in poverty alleviation, if you're interested in anything really, you can tie it all back to climate change, and it's all basically going to be affected. So get into it.
Yeah, that's great. I guess my bit would be, I hope you enjoyed my talk. And I hope you learn how we all rely on energy a lot and those specific tie-ins we have. So anytime you can come up with making a big decision, or you get an opportunity to change the way you interact with energy, just do your research. You don't have to listen to me. Google is amazing. You can find so many great answers there. If you can find multiple scientists that agree, chances are it probably means it's the right thing. So we love arguing with each other, right? If we agree, then something has to be right, because we will find any opportunity to argue with each other. So yeah, thanks a lot. Do your research, and hopefully we'll achieve drawdown soon.
Jermaine, anything you want to wrap up with?
No, just to thank all the speakers, to thank Derek Hall and Laura Gerton of Penn State, Dan King for technical support and putting the links in, and Alon Abramson, Philadelphia Energy Authority, for coming out this evening. Alon, I just also wanted to thank you personally for sort of making social and environmental justice a cause of yours, because it is important to bring everybody along on this journey, because it is a cooperative journey. So thank you for your emphasis in that. I enjoyed that you shared Independence Hall, and you have Billy Penn up there. My grandfather used to be a steeplejack, and he would go to the top of Billy Penn and put on Flyers jerseys on him when they were in the playoffs a very long time ago. So it was a nice reminder of that, and I thank you for your efforts. I thank all the speakers this evening, and I hope everybody comes back for our next climate review series that we're doing with Dr. Gerton. And just thank you so much for everybody coming tonight and considering these issues.
Have a good evening, everyone.
Good night.